In this video, we will explore about how to draw ROC curve as well as mathematics behind it. Also, we see the practical implementation in Python. Pause till end of this video to have a comprehensive understanding of ROC curve. ROC curve, that is the receiver operating characteristic curve. It is the technique which is specifically used to identify best threshold for our model. The ROC, that is receiver operating characteristic curve, is a graphical representation of the performance of binary classifier. It is the plot of true positive rate, that is TPR, against the false positive rate FPR for different threshold values. In a binary classification problem, the classifier assigns each instance to one of the two classes, typically labeled as positive or negative. The true positive rate, also known as sensitivity or recall, is the proportion of actual positive instances that are correctly identified as a positive by the classifier. The false positive rate is the proportion of actual negative instances that are incorrectly identified as a positive by the classifier. So, one way to determine the best threshold is to use ROC curve to visualize the trade-off between true positive rate and false positive rate for different threshold values. The threshold that corresponds to the point on the ROC curve closest to the upper left corner, as it's having highest true positive rate for the given false positive rate. It may be a good choice for our model, as true positive rate and false positive rate are the important components to draw ROC curve. You can also use ROC curve to identify best threshold for the specific class in case of multi-class classification. For that, you have to use one versus all or one versus rest approach. I have explained each and everything about how to evaluate multi-class classification model in the video of how to evaluate multi-class classification model. I will share the link of that specific video in the video description. By the end of this video, you can able to understand how to draw ROC curve and what are the different components of ROC curve. And we'll also see the practical implementation of ROC curve in Python. How ROC curve looks like. ROC curve consists of false positive rate, which is equals to 1 minus specificity on the x-axis and true positive rate on y-axis. True positive rate is also called as sensitivity or recall. In ROC curve, we draw combination of true positive rate and false positive rate at different combination of threshold. So this is the first threshold where we draw a combination of true positive rate and false positive rate. This is the second threshold where we draw a combination of true positive rate and false positive rate. And this is how we can draw combination of true positive rate and false positive rate at different thresholds. But what these points denotes? What is the meaning of these points? We'll see detailed information about ROC curve in the further video. But before that, if you want to know about these terms, which is like sensitivity, recall, false positive rate, true positive rate, specificity, I highly recommend to visit video on model evaluation in binary classification. I will share link of that specific video in the video description. Let's take an example of email spam and not spam data. Our data set consists of two classes, spam and not spam. Consider in our data set we have 3 samples belongs to spam class and 3 samples belongs to not spam class. Let's train a logistic regression classifier on email spam and not spam dataset. Once our model training done, let's use this trained model to draw inferences on the data samples which originally belongs to our dataset. We obtain the predicted probabilities of the each data sample. As we have seen in the ROC curve, each point consists of a threshold value. Now let's apply threshold 1, which is 0.1 on these predicted probabilities. Consider these cross symbols are the probabilities or predicted probabilities of the data samples which originally belongs to the spam class and this tick mark symbol is the predicted probability of the data sample which originally belongs to the not spam class. If the predicted probability greater than zero point 0.1, then it will be classified as a spam, and if the predicted probability less than zero point 0.1, then it will be classified as a not spam. Now let's draw a confusion matrix for this threshold 0.1. Confusion matrix consists of two components, actual labels and model predicted labels. In this case, we have three true positives because here you can see this is the first, second and third. These are the predicted probabilities of the data samples which originally belongs to spam class, and our threshold value also classify it as a spam because its predicted probability is greater than 0.1. So we have three true positives. Now let's move on to the false positive. We have two false positives because this is the first data sample and this is the second data sample, or we can say predicted probability of the data sample which originally belongs to the not spam class, but our threshold value classify it as a spam. So these are the two false positives. This is the first and this is the second false positive. Now let's move on to the false negative. We have zero false negative because there is no such data sample which actually belongs to the spam class, and our threshold value classify it as a not spam. Now we have one true negative. Here you can see this is the data sample which actually belongs to the not spam class, and our threshold value also classify it as a not spam because its predicted probability is less than 0.1. So we have one true negative. Now let's calculate true positive rate. So we have formula for true positive rate equals to true positive divided by true positive plus false negative. Here 3 divided by 3 plus 0 which equals to 1. And formula for false positive rate is false positive divided by true negative plus false positive. That is 2 divided by 1 plus 2 which equals to 2 divided by 3, that is 0.67. So here we have true positive rate and false positive rate at threshold 0.1. ROC curve consists of false positive rate on the x-axis and true positive rate on the y-axis. Now let's draw combination of true positive rate and false positive rate at threshold 1. Threshold 1 consists of true positive rate 1 and false positive rate 0.67. So this is the point of combination between true positive rate and false positive rate at threshold 1, which is 0.1. We can draw the remaining points on this ROC curve by calculating combination between true positive rate and false positive rate at different threshold. So for calculating these combinations between true positive rate and false positive rate, we follow the same process as we did in case of threshold 1. Now let's move on to the second threshold, that is threshold 2. Threshold 2 is equals to 0.2. And these are the predicted probabilities of the data samples belongs to our data set. We can classify these data samples into spam and not spam using threshold 0.2. If the predicted probability greater than 0.2, then it will be classified as a spam, and if the predicted probability less than 0.2, then it will be classified as a not spam. Now draw a confusion matrix for this threshold 0.2. Here we have three true positives. Here you can see first, second, third. These are the data samples or predicted probability of the data samples which originally belongs to spam class and also classified as a spam at threshold 0.2 because its probability or predicted probability is greater than 0.2. So we have three true positives, one false positive. This is the false positive. You can see here, this is the data sample which originally belongs to not spam class, but our threshold 0.2 classify it as a spam. So we have one false positive, zero false negative because there is no such sample which actually belongs to spam class and classified as a not spam at threshold point 2. And true negatives are 2. Here you can see this is the first and this is the second. These are the two data samples or predicted probability of the data sample which originally belongs to not spam class, and at threshold point 2 it also classified as a not spam because its predicted probability is less than zero point 0.2. Now let's calculate true positive rate at threshold point 2. It is equals to, means true positive rate equals to true positive divided by true positive plus false negative. That is 3 divided by 3 plus 0 which equals to 1, and false positive rate equals to false positive divided by true negative plus 1 which is equals to 0.35. So these are the true positive rate and false positive rate combination at threshold point 2. Now let's draw a second point on our ROC curve, that is combination of true positive rate and false positive rate at threshold 2. So we have true positive rate equals to 1 and false positive rate equals to 0.35 at threshold 2. So this is the point of combination between true positive rate and false positive rate at threshold 2. Now let's move to the third threshold, that is threshold 3, which is 0.4. We'll proceed or we'll follow the same process as we did in case of threshold 1 and threshold 2. Here, if the predicted probability greater than 0.4, then it will be classified as a spam, and if it is less than 0.4, then it will be classified as a not spam. This is the confusion matrix for the third threshold, 0.4. Let's calculate the true positive rate. True positive rate equals to 2 divided by 2 plus 1 which equals to 0.66, and false positive rate equals to 1 divided by 2 plus 1 which equals to 0.33. So this is the combination of true positive rate and false positive rate at third threshold, 0.4. Let's draw the third point on our ROC curve, which is combination of true positive rate and false positive rate at threshold 3. So at threshold 3, we have true positive rate 0.6 and false positive rate 0.3. So this is the point of combination between true positive rate and false positive rate at threshold 3. Now let's move on to the fourth threshold, that is 0.5. If probability or predicted probability for the data samples is greater than 0.5, then it will be classified as a spam, and if it is less than 0.5, then it will be classified as a not spam. This is the confusion matrix for threshold 4, 0.5. Let's calculate true positive rate with the help of this confusion matrix, that is true positive rate equals to 2 divided by 2 plus 1 which equals to 0.66, and false positive rate equals to 1 divided by 2 plus 1 which equals to 0.33. So this is the combination of true positive rate and false positive rate at threshold 4, which is 0.5. We have true positive rate 0.6 and false positive rate 0.3 at threshold 4, which is same like threshold 3. So we have common point for threshold 3 and threshold 4 on our ROC curve. So this is the point of combination between true positive rate and false positive rate at threshold 3 and threshold 4. For different thresholds, we can have different confusion matrices, and based on those matrices, we can calculate the true positive rate and false positive rate. ROC curve consists of false positive rate on the x-axis and true positive rate on the y-axis. This is the first point on the ROC curve. It is a combination of true positive rate and false positive rate at threshold 1. This is the second point, and it is a combination of true positive rate and false positive rate at threshold 2. This is how we can calculate true positive rate and false positive rate with the help of confusion matrix at different thresholds. This is how we can draw ROC curve. So these are the all points on the ROC curve and is a combination of true positive rate and false positive rate at different thresholds. This is the final ROC curve that we have obtained by joining the points of combination between true positive rate and false positive rate at different classification thresholds. This is the ideal line where the true positive rate is equals to the false positive rate across all possible classification thresholds. This is the point of threshold where we have higher true positive rate and lower false positive rate. If our problem statement is prioritized towards maximizing the true positive rate and minimizing the false positive rate, in that case we should select this point of threshold, because this point of threshold is the best threshold for your model if you want to maximizing true positive rate and minimizing the false positive rate. These are the point of thresholds where we have higher true positive rate and higher false positive rate. If our problem statement is prioritizes towards maximizing the true positive rate and we can tolerate any number of false positive rate, in that case we should select any one out of these four thresholds. These are the thresholds where we have lower true positive rate and lower false positive rate. If our problem statement it prioritizes towards minimizing the false positive rate and we can tolerate any number of true positive rate, in that case we should select this point of threshold for our model. This is how we can select the best threshold for classifying positive and negative class in our problem statement. Now let's move on to the another evaluation matrix, that is AUC score. AUC score is specifically used for comparison of different kind of classification algorithms. AUC is a single scalar value that represents the area under the ROC curve. This is the area under the ROC curve you can see in the graph. It measures the overall performance of a binary classifier by considering the trade-off between the true positive rate and the false positive rate across all possible thresholds. The AUC, that is area under the curve, ranges from 0 to 1. Higher values indicate better performance. AUC values near to 1 indicate a good classifier with high predictive power, while the AUC values near to 0 suggest a poor classifier. Consider we have trained two different classifiers on our data, that is logistic regression classifier and decision tree classifier. The green ROC curve is for logistic regression classifier and red ROC curve is for decision tree classifier. AUC score for the green ROC curve is higher than that of red ROC curve. You can able to understand from the graph, area under the curve or area under the green curve is comparatively higher than that of area under the red curve. So we can say that this classifier, that is logistic regression classifier, having higher accuracy than the other classifier, because higher the AUC score, better the model performance. In this case, the logistic regression classifier is performing well because it has higher AUC, indicating good predictive power and the ability to effectively distinguish between positive and negative instances. Higher the AUC score, better the model performance. So you can see that logistic regression classifier having higher AUC because area under the green curve is quite higher than that of area under the red curve. Shortly, AUC is specifically used for comparison between different kind of classification algorithms trained on the same data. Now, let's move on to the practical implementation part of ROC and AUC. Firstly, we import all the necessary libraries that we required for our practical implementation. So let's run this cell. Now let's generate a random binary classification data with the help of make_classification function. It is a part of sklearn library. Here you can see I have imported make_classification from sklearn.datasets. Inside that we have to pass different arguments. First argument is n_samples, which is 1000. It is the total number of data points present in our data set. N underscore features, which is 20, it is the total number of features or total number of variables present in our data set. So we have 20 features in our data set. N underscore classes equals to 2. We want a binary classification data. That's why we provided N underscore classes equals to 2. Random underscore state, which is 42, it is the seed for random number generation. Now let's split our data into training and test set. With the help of train underscore test underscore split function, it is also a part of sklearn library. Here you can see I have imported train underscore test underscore split from sklearn.model underscore selection. Inside that we have to pass x. X is the total explanatory variables present in our dataset and y is our target variable. Test size is 0.2 because we want 80% of our data in training set and 20% of our data in the testing set. Random underscore state, which is 42, it is the seed for random number generation. Now we are going to train a logistic regression classifier with the help of training data. For that we are going to call logistic regression function, which is also a part of sklearn library. Here you can see I have imported logistic regression from sklearn.linear underscore model. Now we are going to fit logistic regression model with the help of xtrain and ytrain. That is, we are going to train logistic regression model with the help of training data. Now we are going to predict the probabilities of each and every data sample belong to the test data. So with the help of model.predict underscore probability function and applying it on the testing data, we'll get probability of each and every data sample belonging to the positive class because I have indexed it with 1. So one index is the predicted probabilities of each and every data sample belonging to the positive class. So you can see here, this is the probabilities of data samples belonging to the positive class. If I remove it, then we will get probabilities of the both classes. Here you can see we'll get a list of list. Inner list consists of two elements. First element is the probability of data sample belonging to the negative class and second element is the probability of data sample belonging to the positive class, and we want the probability of data sample belonging to the positive class only. That's why I indexed it with 1. So let's run this. This is the list of probabilities of data samples belonging to the positive class. Now let's calculate false positive rate, true positive rate at each specific threshold. So with the help of ROC underscore curve function, we'll calculate false positive rate, true positive rate at each specific threshold. For that we have to pass actual labels and predicted probabilities for each data samples belongs to the test data set. Here ROC curve is the function of sklearn library. Here you can see I have imported ROC curve from sklearn.metrics. So let's run this cell. With the help of this, we'll get list of thresholds. With the help of this threshold, we can classify positive and negative class. So let's calculate accuracy at each specific threshold. This is the list of thresholds. So we are going to apply for loop on these thresholds and calculate accuracy with the help of this. So firstly, we initialize a list, empty list of threshold underscore accuracy. And again, we are going to apply a for loop on this list of thresholds. And we are going to predict it with the help of this line of code where we are going to use numpy library np.where the actual probability or predicted probability is greater than particular threshold, then it will be classified as a 1, otherwise it will be classified as a 0. That is, if this condition is not getting satisfied, then it will be classified as a 0. So this is our predicted class or predicted label. With the help of this ypred, will calculate the accuracy score. Y-pred is the list of predicted labels and Y-test is the list of actual labels. So we are going to pass actual labels and predicted labels inside this accuracy underscore score function, and finally we append the threshold and its accuracy at each specific threshold. So let's run this. So this is the list of tuples. Here you can see you already append threshold and accuracy inside this tuple. So we'll have list of tuples. The first index of tuple consists of threshold value and second index is accuracy. So again let's print the threshold and accuracy. For that we are going to apply for loop on this list of tuple, that is this list. So let's apply for loop and print threshold and accuracy. So let's run this. We'll have threshold and its accuracy at each specific threshold. As per me, 0.875 is the best accuracy for our model. So we can say that we'll choose a threshold as per accuracy. So I'll choose 0.44 because at 0.44 I am having around 87% accuracy. So that's why I will choose a 0.44, because for other thresholds I am not having that much accuracy. That's why I am going with 0.44. So this threshold. This is the one way to choose a threshold, and second way with the help of false positive rate and true positive rate. So let's obtain the false positive rate and true positive rate. We already calculated it here with the help of this function ROC curve. It will also return false positive rate and true positive rate at each threshold. So let's create a data frame of this false positive rate and true positive rate at each specific threshold. For that we have to import pandas, and we create a data frame with pt.data frame. Inside that we have to pass false positive rate as a key, and its value is actual list of false positive rate. This is the second key, true positive rate, and its value is true positive rate that we have obtained on this line. So this is the code of line where we have obtained true positive rate, and the third column is thresholds. So let's run this. We'll have false positive rate, true positive rate and threshold. In the first column we have false positive rate, in the second column we have true positive rate, and in the third column we have threshold. So as per our problem statement we can choose our threshold. If our problem statement prioritizes to us maximizing the true positive rate and minimizing the false positive rate, we'll choose our threshold value as per true positive rate and false positive rate. We choose threshold where we have maximum true positive rate and minimum false positive rate. So as per me, at 90% true positive rate, I am having threshold about 0.29 and false positive rate is about 21%. So this is the best threshold for me, because at this threshold I am having minimum false positive rate and maximum true positive rate. Because as I go down I'll have maximum true positive rate, but in those cases I'll have maximum false positive rate also. That's why I'm not going to choose these thresholds, because it's having higher true positive rate and higher false positive rate. So at 0.29 I am having about 90% true positive rate and 21% false positive rate. So I'm going to choose it like the threshold where I have maximum true positive rate and minimum false positive rate. You can choose as per your problem statement. If your problem statement prioritizes towards higher true positive rate, then you will choose just like me. If your problem statements is only focus on false positive rate, like you want a minimum false positive rate and you can tolerate any number of true positive rate, in that case you choose value like 0.89 where we have minimum false positive rate, but we also have around 49% true positive rate, which is not good. But if you focus on false positive rate, in that case you can choose this threshold because it is having minimum false positive rate. This is how you can choose best threshold for your model to classify positive and negative class. Now let's create a ROC curve with the help of this false positive rate, true positive rate and thresholds. Now we are going to create ROC curve with the help of this PLT. I have imported matplotlib.pyplot as PLT already. So let's create a ROC curve. Firstly, we initialize it with plt.figure. It will just create a window for our graph. Again, inside plt.plot function, we have to pass false positive rate, true positive rate, color of our ROC curve is green, width of line is 2, and label is ROC curve, and it is formatted with AUC score. AUC score is calculated with the help of AUC function. It is also a part of sklearn library. Inside that we have to just pass false positive rate and true positive rate. Again, this is the line where it is helpful to draw an ideal line for our ROC curve. This is the line where the true positive rate is equals to the false positive rate. Color of this line is gray, width is 1, and line style is just dash line. Now again we are going to limit x-axis and y-axis and labelize the x-axis as a false positive rate and y-axis as a true positive rate, also providing title as a receiver characteristic, operating characteristic curve, and again our legend at the lower right corner. So let's see this ROC curve. This is our final ROC curve. Here you can see false positive rate on the x-axis and true positive rate on the y-axis. So this is the ideal line where the true positive rate is equals to the false positive rate. So with the help of this line, we just created this line. With the help of this line of code, we created this line. So for this ROC curve, we have around 0.92 AUC. So this is the AUC score. It's about 0.92, which is quite good. So as per me, these are the base thresholds where we have a higher true positive rate and lower false positive rate. So as we have choose around 0.29 is our threshold uh, where we have around 21.21 false positive rate and 0.90 as a true positive rate. This is our threshold value, okay, because our true positive rate is about 0.90 and false positive rate is about 0.21, so it may be this point, okay. So this is the final threshold for our model to classify positive and negative class. Now let's move on to the next part, that is AUC. AUC is specifically used to compare different kind of classification algorithms trained on the same data. Now let's train another classifier, that is decision tree classifier. So I have imported it from sklearn library. So here you can see I have already imported it from sklearn.tree. So let's train our training data or our model with the help of training data. Here you can see we'll follow the same procedure as we have done in case of logistic regression. So let's run this cell. Now we have our model, decision tree model. Let's predict probabilities of the test samples. With the help of this ROC curve, we obtain the false positive rate, true positive rate at each specific threshold for decision tree classifier, and with the help of AUC, we obtain AUC score for each ROC curve. So let's obtain AUC score for logistic regression by passing false positive rate for logistic regression and true positive rate for the logistic regression inside this AUC function, and this is the AUC for decision tree. Inside this we have to just pass false positive rate for a decision tree. That is, here you can see I have passed false positive rate underscore dt. It is a false positive rate for decision tree and true positive rate for decision tree. So this is the AUC score or AUC for logistic regression, and this is the AUC for decision tree. So let's run this. Let's print AUC for logistic regression and AUC for decision tree. So as you can see, AUC for logistic regression is about 0.92 and AUC for decision tree about 0.87. So as we know, better the AUC, higher the model performance. So we should go with logistic regression because AUC score for logistic regression is quite good as compared to the AUC score for decision tree classifier. So we should go with logistic regression. Let's plot the ROC curve for both the classifiers. I am going to use the same function that I have used earlier. I just copied it and added one line only. So you can see this is the another line where we plot ROC curve for decision tree, and inside that in this line I just passed AUC for logistic regression that we have calculated here and AUC for decision tree that we have calculated here. Here you can see, and the remaining code is same that we have used earlier in this function. So let's run this. Here we have two ROC curve. Red is for decision tree and green is for logistic regression classifier. So ROC curve for logistic regression consists of AUC around 0.92 and for ROC curve, that is decision tree, for this red curve we have AUC about 0.88. So from this graph you can able to understand AUC for the green curve is quite higher as compared to AUC for the red curve. So we should go with logistic regression because it's having higher AUC score. This is all about how to draw ROC curve and how to use it in your machine learning modeling. Thanks for watching. If you enjoyed the video, please subscribe my YouTube channel and see you in the next exciting video.